So the period is how long the function goes before repeating itself. Essentially, how long does it take to get around the unit circle? Because that's what you see here is 1 period of the sine function. So from, it has to go through the hill, go through the valley. Or if it was cosine, it starts on the top, then it ends on the top. Or if it were to start on the bottom, you'd want it to end on the bottom. That would be 1 period for each. So once again, for sine, the period is going from starting on the midline, going through a hill and a valley. That would complete a period. And cosine, completing a period would be if you start on the top, how long it takes to get back to the top, or if you were to start on the bottom, how long it takes you to get back to the bottom if it starts on the bottom. That's the flipped cosine case when that happens. So how long does it take basically to get through the unit circle? And what happens is this number in front of x can speed up the process of going through the unit circle. Think about it. If we put a 5 in front of x, it's going to go through the unit circle 5 times as fast. If we put like 1/5 in front of x, it's going to take a fifth. It's going to slow it down. It's going to be pulling it back a fifth of what it would normally be at. So it would slow it down and make it longer. So let's go ahead and take a look. Let me pull up a graph. I should have had that ready to go. So let me see trigonometry, but I know period is right here. So you could see if I increase b, I don't really like this example. That's actually changing the period perfectly. Let me go ahead and change it to the way I want it to be for this example. Oh no, that's A. I don't want to mess with A. There we go. Okay, let's put B at 1. So if I make B greater, what you're going to see is it's going to just kind of like an accordion. It's going to squeeze it together so that period is actually going to shorten. Compared to if I make it a smaller number, it's going to take longer to get through the period. It's a smaller number. And so you can see how it gets kind of wider, stretches it out. So what's the formula for this? This is a quick formula. It's just 2 pi over b. Remember, b is the number in front of x. So for this, what's the period? We're going to do 2 pi divided by 2. Where did I get 2? From right there. So this one's going to have a period of pi. So it's going to go through its sine, so it starts in the midline, going to go through a hill and a valley. And the length that it's going to do it, the distance from here to here is going to be 2 pi. Not 2 pi, 1 pi. Looking at this one, there's our b. So 2 pi divided by the absolute value of 7. It's just 2 pi over 7. Not really anything we could do about that. So it's going to be a really short period. This one, this time we have pi over 8. So we're going to have 2 pi divided by pi over 8. Now realize now we have a fraction over a fraction. The 2 pi is technically the top fraction. So we got to flip and multiply. And the pi's will cancel out. 2 times 8 is 16. So this is a long period. What will happen here is this is cosine, so it's going to start. Actually, it's a negative cosine because the negative, it'll start on the bottom instead. So remember how it starts on the bottom and then it'll end on the bottom. The midline will be at 3, right? That we know the midline there, but we're not really worried about the midline. I just want to show you this one's going to actually get stretched out though, because 16 is relatively long for that. So the distance from here to here is 16. Then last for this one, remember that absolute value part of the formula? I guess finally we can use it. So remember that's going to be 2 pi over 1 over 3 pi over 4. Just went ahead and got that common denominator while I was at it, since I had to do that extra step, times 4 over 3 pi. And that's going to be 8 over 3. And there you go.